Hello everyone. So we are continuing with our top 100 liked LeetCode problems, and today we will pick this search in rotated sorted array problem. So let's see the problem. So you are given an array and it is sorting in ascending order with distinct values. Now, prior to being passed to the function, the array is possibly rotated at an unknown pivot index. So it is like it is rotated. We will see it in the example. And for example, let's say this is the original array which is sorted. The input could be rotated at index 3 and it will become 4 5 6 7 0 1 2. So it means 0 1 2 is shifted in the right and 5 6 7 is circled back. Now after the rotation you are given the array and the target. Now you have to return the index of the target if it is present in the array, or you have to return -1 if it is not present. So if we do not rotate the array, it is actually a binary search problem, right? Everyone knows the binary search. We just binary search and we find the index or -1 if it is not present. But in this case, the array is rotated, which makes it little bit difficult to search. And the thing is, you have to do it in log n time complexity. So you have to do it in the binary search sort of format only. Okay, so let's see. Let's go to our whiteboard and see how we will solve this. So let's say the input is 4 5 6 7 0 1 2. This is the input and your target is, you have to find 0. So everyone can see that this is not a sorted array, right? This is not a sorted array, so you cannot do the binary search and you cannot even linearly traverse it because it will be order n. So how we will do it? Now if I tell you, so actually first of all there are many different ways to solve this problem. There are many popular ways online to solve this problem, but I will take a little different approach here. I will divide this problem into two parts and solve them separately, which will make it easier. So let's do that. Now if you look at this, you can divide this array into two parts and we can say both of these parts are sorted. Now if I can divide this array into two parts, I can easily do the binary search on both the parts, right, and find whether the element is present or not. We can do a simple binary search on these parts, but we cannot do the binary search on the complete array because it is not sorted. So now the question is, how do we divide the array in these two parts? And you can see we only have to divide the array in two parts only because it is rotated. Now let's say the array is not rotated. It looks like 1 2 3 4 5. In this case we don't have to divide it at any parts. It is in a single part only, which is sorted. Now if I rotate it in some way, for example I rotate it 2 times and it becomes 1 2 3 4 5. Now you can see, now you have to divide it into two parts which are both sorted. So I have reduced the problem to dividing this rotated sorted array into two different sorted parts, and then we can do the binary search. So the problem is, how do we find this, that how to divide it into parts? So basically if you see, we have to find the smallest element in the array. We have to find this smallest element, and at this element we will divide the array into two parts. Okay, so how we can do this? So basically we can again do the binary search to divide the array into two parts. So how we can do, for example, let's look at the previous example, 4 5 6 7. So we want to divide it into two parts. So what we can say, we will assume, so now if you look at this, if you take the mid of this, let's say the mid is 1. Now is this value, if this value is, and if we can compare this with the first value. Now if the first value is larger than this, then we can assume that this part lies in the second half. because if they, for example, if you compare these two values, first value is less than this, it means this lie in the first part. So in that way we can do the binary search. So now let's say we are at here, this is our mid element and this is 4, so 4 is greater, so we will now try to divide it because we know that that first index will lie here. Again we take a mid here, this is greater than 4, so the mid should lie, the pivot should lie here, and at like this we can find this 0 and we can divide the array into two parts and we will call it as a pivot index. So like this we can solve this problem. So let's try to code it, and with that we will understand more. Okay, so let me write a function which is called find pivot, and it will take the rotated array. Now what should we do? We can say we will start the left index from 1 and right index from the last index, and now we will say while L is less than R, we will simply do the binary search here. Here this is the middle index, L plus R by 2. Now if nums of mid, if the middle index value is greater than equals to the first value, it means it is in the, we are in the first half. So we can say L will become mid plus 1 because we will now explore the second half of the array. Otherwise, if this is not the case, if nums of mid is less than nums of 0, then this could be our pivot as well. So here now R will become mid. After this all is done, now we can check if nums of L is less than nums of 0. It means that if the middle, if any value which is L, which is from 1 to last range, if you see this is what 1 to n minus 1. If the range from 1 to n minus 1, if this value is less than nums of 0, it means we have found the pivot, which is L. If it is not, then we can just return 0. 0 says that the pivot is in the first index only, which actually shows that array is not rotated at all. And here we can check one more thing, that if L is equals to R, only then the loop will break. Okay, so with this we have found the pivot. Now we will take the pivot let's call it P only. Now we have divided the array into two parts. Okay, now let's go back to our board. Now say we have divided our array into two parts. Now what we can do, we can check the target value. Target value is 0. So if the target value is, we can compare with this first last value 2. If the target value is less than 2, it means it is in the second half. If target value is greater than this, then it means it is in the first half, because you can see 2, all the values here are larger, 4, 5, 6, 7. So now we can do the second part, we can do the binary search. Now here we take nums size. If nums of n minus 1, target is less than that, target is less than, then it is in the second half. So we return the binary search. We binary search from in the second half. Second half means from P to n minus 1, because second half starts from P with the target. Otherwise we do the binary search in the first half, which is first half is 0 to P minus 1. Second half is p to n minus 1. First half is 0 to p minus 1. Now everyone can see, okay, this binary search function is not available. I mean, it does not return the index. So we will write this binary search function. So it will take our array. It will take start and end index, and it will take the target. So now what we will do, while regular binary search start is less than equals to end, now if nums of mid is equals to target, it means we have found the target, we return this index. Else if nums of mid is less than target, it means we have to go to the right side. So start will become mid plus 1, else start will become end will become mid minus 1. And if we do not find any element after this while loop, we return minus 1. So let's try to run this code now. It's a little bit bigger code, but I have divided the code into two parts and they both are easy to understand. They both are sort of binary search in themselves. So you can see the code is correct. It is correctly running. Okay, so if I summarize again, what we did, we first find the pivot at which the array is rotated. If we do not find it, we says array is not rotated at all and pivot is 0. If pivot is 0, we can see the target will always be less than equals to nums of n minus 1 if the array is not rotated. So we will just do nums of 0 to n minus 1. So it is a regular binary search. But if it is rotated, we do it in the second half. And if it is target is greater, then we do it in the first half. And this is our regular binary search. So basically, if we do not find the pivot, there are different approaches which only use the binary search, then it will make your binary search complicated. It will have many different edge cases which you need to consider. But if you divide the problem into these two parts, it is very easy to solve and it is very easy to understand as well. So with that, we are done with this question. If you have any doubts, because there could be some doubts with this question, just drop it in the comments. I'll handle them. And if you like this video and if you want to see more such videos, you can subscribe to my channel. I'll keep posting such questions, solutions on that. So until the next video, bye bye.